I wanted to refine my custom G-code system and show more details about how it works. But I needed a new project, and I had been wanting to update my enclosure system for my M8 Tracker for better integration into the mobile Cyborg orchestra. So I designed a faceplate as the first component, thinking about things like cities and communicators. I start with an outline, add cutouts for components, extend bridges to connect all islands, preserving single path continuity, piping to fill empty spaces. Get the cross section, select the canvas portion, add custom glyph, complete. I asked my assistant to help me build a web shop that's hosted with GitHub pages, so it's easy to push updates from VS Code. Then we wired up a backend server on a DigitalOcean droplet and connected it with Stripe, so that I have all the basics of a shopping site without being tied to a specific platform or framework. We also made an interface for customizing an order with a custom glyph, and during checkout, that gets sent along with Stripe's customer information to the backend, where I have a custom admin interface for tracking orders and copying the glyph data to paste into Grasshopper for generating the part. I have my printer cam set up as a phone with a macro lens attachment, but I want the camera to follow the nozzle to maintain better focus. I'm thinking about a simple pulley mechanism that converts the x-axis motion of the print head to a pivot. I started by opening up the G-code for a print I made with my slicer. I'm using VS Code, which makes it easier to read. I know I want everything up until after it primes the nozzle, and then replace everything after that with my custom G-code. I'll copy everything before the first layer change, then paste it into a panel in Grasshopper. Then I'll just grab the small routine at the end of the G-code, and now all I have to do is generate the code for the actual printing. Someone suggested that model airplane wings would be a good use case for this, so I mocked up a test part for this example. First, to get curves for each layer slice, I made a series of numbers for the layer heights, put a plane at each height, and intersect the planes with the model. Then I make sure those curves are in order from bottom to top, and move them into the correct position for my printer bed. This button prevents the downstream G-code generation from running as we adjust the model and the slices. Here I create lists of feed rates and extrusion multipliers to match the list of layer curves. Then I add a small radius to the sharp corners of each curve. This is where we go from a list of curves representing each layer to a list of lists for the individual segments of each layer, and a list of lists for the points of each layer. I'll then separate the first point of each layer from the rest. Here I take that first point, get the z-coordinate, round it to 3 decimal places, then combine it with the other text in the G-code line. Then I take the x-y coordinates of the first point and again create a line of text for the first xy move. Then I'll take the list of feed rates I set up for the next line. And now I can take the xy coordinates for the rest of the points, multiply the length of each segment with the extrusion multiplier list, and combine those to generate the lines of G-code that complete each layer. Here I take the z height of the final layer to have the printhead move up at the end. We can then merge each component of the layers into one chunk of text, and then merge that in with the beginning and ending routines we copied over from the slicer's G-code. Now we can set this final combined chunk of text to stream out to a file destination, and whenever we hit that play button in the Grasshopper script, the file will be updated.